Ayan. So once again, good afternoon. So today we're tackling two LGs. So first, we have LG 1.2 dealing with enthalpy and LG 1.3 that deals with our Hess's law. But before we go into that one, so let me touch base muna with you guys. So I'd just like to ask if there were any problems or difficulties ba regarding our last now formative assessment last week. Any difficulties, concerns, or any comments whatsoever regarding last week's formative assessment? Okay, so Sandra says wala naman. Okay. All right, so we have already the answers naman from our classmates. So I'd also like to apologize to Kauri. So I wasn't able to reply to you pala regarding your inquiry. So I just saw it, but I was quite busy at that day. So I forgot to actually reply to you back. But I hope naman na at least to solve mo naman what to do there. So okay lang ba yun, Kauri? Okay. Sige, thank you so much. So just pardon me if sometimes I forget to reply. If you really need to ask questions lang, just, tawag nito, just try to double back lang and ask if you really need more help. Since sometimes we could be really flooded with mga messages, so sometimes we do forget. So I do apologize for that one, and please bear with me na lang. So anyway, so that's that. So moving on to today's agenda, so we're gonna do the following. So first up, we'll have our activity, which aims to simply allow me to measure how much you've understood from our video for the week and also our learning materials na posted sa K-Hub. After the activity, that is when we go to the lesson proper. In the lesson proper, since na-introduce naman ang concepts sa inyo in the video of the week, so we'll focus more on any questions that you have, any misconceptions that arise, that I see from your performance activity natin today, and other questions and concerns that you might have. As well as also some other examples para lang ma-deepen natin ang understanding about today's topic. And finally, after the lesson proper, that will be the other reminders that we have. Okay, so that's the agenda for today's meeting. So what I'd like you to do now, guys, is to please go to menti.com pa rin. And this time, please use the code that you see on the screen. So the code is 84804513. That's 84804513. So you could participate in today's activity. So again, please go to menti.com and use the code that you see on the screen to be able to participate in our activity for today.
Dili pa daw open, sir.
Okay. Sige. I'm still having a little bit of difficulty with my ano. But anyway, just go to Menti na lang muna while I try to resolve this one. So thank you sa feedback. Ayan, so we now have 20 players all in all. So let's wait 1 minute more for the rest to arrive so that they could also participate. So once again, that's menti.com using the code 84804513. While waiting, you might want to get your calculators ready as well since meron dito mga computation na questions. So we're still waiting for 4 more people. So while we wait, so let's give them 1 more minute. And meantime, pakikuha na lang na ating calculators so that we can answer the activity. Okay, so I think we're now ready to start our activity. So if you have your calculators ready, so we're now going to start the activity as follows. So first up, so kindly please enter which of the following is true about delta H for a constant pressure process. Is it delta H is equal to Q? Is it delta H is equal to delta E? Or delta H is equal to W? Okay. So checking our answers now. So the correct answer here is the first choice. Delta H, a constant pressure process, is always equal to our Q. Okay, so good job on the 12 people who got the correct answer. So this time, I'd like to solicit your ideas in here. So based on your understanding ng ating video and the learning materials, so what is the sign daw of delta H for an endothermic process? So kindly please type your answer for this one. So going strong si positive. Meron bang gustong maiba? would like to have a different answer? Positive, yay. Okay, so naiba naman siya kahit pa paano. Okay. Sige, so an overwhelming majority naman answered that delta H is positive for an endothermic process. So that one is correct. Pag endo, also noted in here, although not siya all about sign, but when you're talking about endothermic process, it is a process that absorbs energy from the surrounding, or heat rather from the surrounding. So its delta H is positive in sign. Pag exo, on the other hand, it releases heat to the surroundings, and delta H has a negative sign. So I'm glad that we have that one correct. Moving on to the next question. So please keep your calculators ready for this one. So a gas is compressed from 0.05 cubic meter to 0.02 cubic meter. So please calculate delta V in cubic meters. So you have 45 seconds. In your final answer, please be sure to enter the unit. The unit of the delta V. So 20 seconds left. So what is the delta V in cubic meters for the gas being compressed? Okay. Medyo kakaunti lang nag-answer. But in any case, let's see what the correct answer is. The correct answer is negative 0.03 cubic meter. Okay. So we have the correct answer. We just have one since siya lang may unit. So of the two people na meron namang correct value, again, hindi pa rin siya counted because we need to have the unit always for this one. So hopefully in the next round, more of us can already answer for this one. So again, calculations pa rin ito. Keep your calculators ready for this one. So a gas is compressed from 0.05 cubic meter to 0.02 cubic meter by a constant external pressure of 200,000 Pascal. Now please calculate the work in joule. So in your final answer, please write the unit na capital J for your answer to be considered correct. So we have 15 seconds on the clock. So para sa iba, habol-habol naman tayo, guys. Ayan, time's up. So checking the answer, the correct answer here is 6,000 joule. So we have one person who got the correct answer for this one. So congrats on that person who got the correct answer. So please take note of your answer from the previous. The correct answer was negative 6,000. So this time, let's now proceed to the next question. Again, recall negative 6,000 yung answer kanina. So this time, please compute delta E. If this time, 3 kilojoules of heat is also removed. Again, recall the answer earlier was negative 6,000. Correction, 6,000 dapat ang answer pala kanina. 6,000 joules ang previous answer. So the correct answer here is, for this question, it's equal to 3,000 joules or pwede rin 3 kilojoule. Again, please recall na when you're talking about kilo, a kilo is equal to 1,000 of something. So 1 kilojoule is 1,000 joule. So we have 2 persons who got the correct answer for this one. So congrats on getting the correct answer for this. And then we have question number 5. So this time, we're now looking for delta H. Taking note of the answers earlier, 6,000 joules ang ating work, W. 3,000 joules ang ating delta E. This time, please compute the delta H. So this time, you have a constant external pressure and 3 kilojoules is being removed. So for the others, please try to catch up. So we have more na answers. So the correct answer here is negative 3,000 joules or negative 3 kilojoule. Actually, for this one, you don't need to solve it. Ang sabi naman dito is constant external pressure siya eh. Now recall, earlier you were asked, delta H is equal to Q daw pag constant pressure tayo. So you just have your answer here, na 3 kilojoules of heat being removed. So mathematically, that gives you now your correct answer. So out of the 13, we have 4 people rather, who got the correct answer. So congrats to you guys for getting the correct one. 5 rather. 5 people who got the correct answer. 6, if counted itong si isa, na walang space bar between sa negative 3 and kilojoule. And for this one person who got 3 kilojoule lamang, again, please read carefully. Sabi niya is, heat is removed. So recall from the last lesson, pag heat is being removed, negative ang sign ng Q. So congrats on the 6 people rather, who got the correct answer. Now for this one, I'd just like to solicit your opinion in here. So, in the very last part ng ating video, so we discussed how to interpret the thermochemical equation. You have a thermochemical equation in here, as shown. So kindly please fill in the blank. 1 mole of our urea reacts blank 15.4 kilojoules of energy. So what should I write here on the blank? Is it released or is it absorbed? So kindly type your answer kung release ba or absorb. Okay, for the rest, can we still catch up? So is it release or absorb to complete this sentence? Okay. So the answers are all in. And basically, we all agree naman. So the majority of the answers are, to complete the sentence, the word should be absorb. So that's correct. Absorb or absorbs. So 1 mole of the urea is reacting, absorbing now 15.4 kilojoules of energy. So absorbing is the correct answer in here. So let's check our scoreboard. So leading the scores with 1753 points is Paul. So congrats, Paul. Followed by Jade. And rounding up the top 3, we have Sophia. So congrats, guys, on getting the highest points for this activity. So for the rest of the top 10, congrats as well. To those who didn't manage to get into the top 10, so better luck na lang next time. And hopefully naman, at least, we can be able to do a little bit better in the next activities. Okay, so let me go back to my PowerPoint now. So at this point, so let me turn it over to you guys muna. Do you have any questions ba or concerns regarding our activity today?
Sir, dito ko sa
Yes, thermochemical equation.
O kato. If katong change in enthalpy god kay positive. Katong positive na dayon tong kuan. Ay mag-absorb na dayon na siya.
Yes. Positive
Okay.
delta H meaning it's absorbing. Negative delta H, it means na it is releasing.
Thank you, sir. Thank you.
Okay, thank you, Paul. So maybe next time also we can try to practice speaking in English in straight na conversation. So other concerns, please, that you'd like to bring up? Questions? Concerns? Clarifications? Violent reactions?
None po, sir.
Okay, Sandra, Sophia, thank you so much for feedbacking on that one. Sige, so let's now proceed to the actual na lesson natin at hand. So our target na ma-achieve for this particular session are the following. So first, by the end of this learning guide module, the students should be able to define enthalpy, differentiate endothermic and exothermic processes, and analyze exothermic and endothermic processes energy diagrams. So let's get into it. So last time, what we had was we were able to discuss the internal energy. Now, as we noted, every time that there is a chemical change going on, guys, so it's always gonna be accompanied by a change in energy talaga. However, the delta E is most conveniently being measured in instances of constant volume. However, in our daily lives, what we encounter is that ang mas karaniwan natin na encounter is ang constant pressure na process. Like for instance, if you boil off our water in the boiling pot, so that's an example of a constant pressure process. In a constant pressure process, the pressure of the system does not change throughout the process. So that's the more common situation that we encounter. Now, delta E, if we're gonna do experiments, we can very easily measure delta E just by knowing na pag constant volume process, delta E is always equal to QV, where V is the subscript indicating a constant volume process. Now, what we're interested to know in is there a related quantity ba that we can relate to equation number 5, pero this time using our constant pressure process? So dito papasok ang ating enthalpy, which is the subject of today's activity. So enthalpy is defined as follows in here. So enthalpy is a quantity similar to the internal energy. The symbol of enthalpy is capital H, and it is defined as the sum of the internal energy plus the PV work. The PV work, yan yung work na ina-accomplish ng ating gas as it expands or compresses against a constant pressure. Now, the change in the enthalpy is then defined by equation number 7 shown in here, where delta H is also equal to the final enthalpy of the system minus the initial enthalpy of the system. Now, tulad ni internal energy, so again, we have to emphasize na enthalpy, like internal energy, is a quantity na we cannot measure directly in the laboratory. It's only the delta H and the delta E that we can be able to observe directly and measure. So that's why we're so interested in the equation number 5 in here and a related equation to this one. So luckily, we have defined enthalpy such that when we have a constant pressure process, guys, our delta H should always be equal to the QP. The P na subscript represents here a constant pressure na process. Now, like our delta E, ang delta H could be positive in sign or it might also have a negative sign as well. So let's see ano bang significance ng positive na delta H na sign and the negative delta H na sign. So here is where we talk about exothermic and endothermic processes. Exo, it's releasing heat to the surroundings. And when you have an exothermic process, delta H is negative. Now, on the other hand, when you have an endothermic process, the process, or the system rather, is absorbing heat from the surroundings. So delta H is gonna have a positive value. So in experiments, you can actually determine whether an exothermic or endothermic process is taking place just by touching the container in which the chemical change is happening. Pag exothermic process, you feel na habang tumatagal, it seems like the container on which the reaction is occurring gets hotter and hotter. That is a manifestation that heat is being released to the surroundings. And that's how you know na you have an exothermic reaction. Pag endothermic reaction, it's the opposite. As the reaction occurs, you might notice, holding the container, that it gets colder and colder as time goes by. That's your clue that an endothermic reaction has taken place. So together, the delta H value is actually always combined with the balanced chemical equation to make up our so-called thermochemical equation. So in the thermochemical equation, what we observe is the following. So meron tayong balanced chemical equation, first written. Every substance that is involved in the reaction has its state given in here. So the states of our substances must always be specified because changing the state of a particular na substance would change the delta H value. For instance, if instead of liquid water, I wrote in here instead a liquid gas, water as a gas rather. So what's gonna happen is, ang delta H natin magbabago rin siya. So the value of the delta H in the thermochemical equation depends on the state of the chemical species. That is why we always have to specify whether it's a solid, a liquid, a gas, or an aqueous na species. Again, as noted in the video, in case you might have missed that part, aqueous meaning that substance is dissolved in water. So you might wonder, so you have a very packed na representation in here. But how do we actually interpret this one, this thermochemical equation? So from the thermochemical equation, we're now able to pull out a lot of information in there. So in that previous na thermochemical equation, we can now surmise that the following is true. If we look at the coefficient ng CH4, for instance, CH4 has a coefficient of 1. We just didn't write 1 because understood na iyan. That CH4 has a coefficient of 1. So seeing that you have 1 mole of CH4 in here, 1 mole of CH4 in this reaction will now always produce, or rather release, 890.8 kilojoules of energy. Now, in our activity, you were asked the opposite. If delta H daw is positive, ano ba kaya ang ating statement dito? So pag negative, the energy is being released. Pag positive, on the other hand, energy is being absorbed. Again, take note of what the sign of delta H indicates. When delta H is negative, energy is being released to the surroundings. Delta H having a positive sign, meaning that the energy is being absorbed by the system from its surroundings. So we can do this for each chemical species that we have. For oxygen, we can say the same thing. Since the coefficient of oxygen is 2, we can then write that 2 moles of oxygen is reacting here to release 890.8 kilojoules of energy. Now going over to the product side, again, we can look at the coefficient of carbon dioxide. Since its coefficient is 1, we then say that in this reaction, 1 mole of carbon dioxide is produced, accompanied by the release of 890.8 kilojoules of energy. And same with the water, we can also state the same thing. Now, these statements are really quite handy whenever we have a stoichiometry problem that relates to our thermochemical equation. So for instance, you have in here highlighted this particular na statement. 1 mole of CH4 reacts to release 890.8 kilojoules of energy. So what we can do now is, we can now be able to write the following na statements from this one. So base dito, we can now write the following conversion factors. We can then write 1 mole of CH4 Let me write a subscript muna. Ayan. 1 mole of CH4 for every 890.8 kilojoules of energy being released. That's one conversion factor that I can write. Similarly, I can just try to flip over this conversion factor I wrote in here. So instead, ang 890.8 kilojoules, I can write it on the numerator. So that this time, we might also write as well 890.8 kilojoules for every 1 mole of the CH4. So these are the conversion factors that I can now write. Okay. So that comes from the statement that we have in here. So this time, what I'd like you to do is please look at the next statement. 2 moles of water is produced with a release of 890.8 kilojoules of energy. So this time, let me turn it over to you guys. What I'd like you to do now is please tell me what conversion factors can I write from this particular statement. So you might want to unmute yourself or type sa chat box. What do you think? Ano kayang conversion factors can we come up with in here? You might choose to type your conversion factors sa chat box. Or pwede rin naman na i-unmute yung sarili nyo to state it out. So just give one. Just one conversion factor. Okay, so Sandra has her answer. So she wrote 2 moles. Pwede nang alisin si of. 2 mole H2O na lang over 890.8 kilojoule. So that's one statement. Can I have another na conversion factor? So can somebody else please type on the chat box? What other conversion factor can we write in here? So Sandra got that one correct. So what we need now is the second conversion factor. So again, feel free to unmute yourself to answer, or you can just type in the chat box. Okay, Yisha has her answer. So Yisha, what we're trying to focus here is the water, not the carbon dioxide. So meron na isang statement from Sandra. So what we just want is a different statement for the water. Although correct naman ang answer mo, Yisha, actually. But water ang ating gusto i-focus. So Chelsea got the correct answer. So you just simply flip it around, get the reciprocal of Sandra's answer. So that's how we got 890.8 kilojoule per 2 moles of water. So both Sandra and Chelsea have the correct conversion factors for this one. So typing that up, we now have, so one conversion factor would be 2 moles of the water for every 890.8 kilojoules of energy, or we can also state that we have 890.8 kilojoules of energy for every 2 moles of water. Thank you for your answers, Sisha, Sandra, and Chelsea. So we're interested in writing the conversion factors because it is these two that we're gonna be using when we're dealing with stoichiometry relating sa thermochemical equations. So you might recall in our Chem 1, you spent probably a lot of time in the stoichiometry na portion ng ating lessons. So basically, we're just going to rehash that one in here. So you have in here a copy of the periodic table. I'll just give you a copy of this one so that we're gonna be using the same periodic table throughout. So using this one, let's try to answer sample problem number 1. So in sample problem number 1, so can I please ask a volunteer to read for the class the question? Just a question lang. Never mind muna itong equation sa baba.
Sir,
Yes, please.
calculate the heat absorbed when 5 grams of solid ammonium nitrate is dissolved in water at normal room temperature and constant pressure.
Okay, thank you so much, Kauri. So thank you also to those who raised their hand to read this one. So what we do now, so we're interested to find how much heat is being absorbed. So summarize muna natin ha. What we're given here is the following equation. So we're given the following information. So namely, our balanced thermochemical equation, which is this one. So that's always very important to have. Other information that we have rather in the problem are the following. So sabi sa problem is that you have 5 grams of the solid ammonium nitrate. So copy ko na lang para mas mabilis. So also given to us is this amount. So what we're looking for is we're supposed to find how much heat is being absorbed. How do we go about doing this one? So what we do is we just have this mass of sodium nitrate as our ammonium nitrate rather as our starting point. So copy lang natin yung given information na iyan from our problem. We have 5 grams of ammonium nitrate. The solid one, to be precise. And this time, we'll try to multiply it to conversion factors so that we arrive at the quantity that's being asked of us. So looking at our periodic table in here, sa taas. So for our nitrogen, it's right over here. It's 14.007. Hydrogen, it's right over here. Its atomic mass is 1.008. And oxygen is 15.999. So recalling in our Chem 1, how to compute the molar mass, we can then have the following. So we can now write that 1 mole of the ammonium nitrate is gonna be equal to, let's use the periodic table for this one. So N, that's 14 point, check, 007 times, there are 2 nitrogens, 1 nitrogen, 2 nitrogen, so times 2, plus the hydrogen, which is 1.008. There's 4 of the hydrogens, plus the oxygen, that's 15.999 times 3 of the oxygens. So that gives me a total molar mass of 80.043. So let me type it in here sa baba. .043 grams of the ammonium nitrate. If you look very closely, guys, you might notice the way I wrote this one. I wrote this particular na equation in here such that itong gram na ito, this gram over here, is directly opposite to the grams ng molar mass. What's gonna happen now is that the unit of the grams will cancel out. So the gram in the denominator cancels out the gram in the numerator sa ating given value. And ang matitira na lang ngayon is moles na lamang. Okay? So can you please try to compute this one for me? So how many moles of ammonium nitrate do we have? So again, feel free to unmute yourself to answer or just type your answer sa chat box for this one. Paul, do we have an answer?
0.06 moles, sir.
Okay, so 5 over 80.043, that's 0.06 mole. So 0.062.
Oh,
So again, please observe always the correct number of significant figures. Ang answer natin dapat may 2 significant figures. So Yisha, Sandra, Chelsea, Chelsea, naglapas lang tayo ng isang significant figure. And Kent all have the correct answer. As well as Kyla. However, hindi yan ang ating hinahanap, guys. What we're looking for here is the amount of heat being absorbed. So what we do now is, once again, we look carefully at the thermochemical equation, and then we write a conversion factor, same as what we've done earlier. So the answer that you got in here, we still need to multiply it even further. So magmumultiply pa tayo so that we have the following. So let me move this one to the side so that there's space. Okay, moving that. So looking at this thermochemical equation, we can now try to see ano bang conversion factors ang posible dito. So again, let me hear from you guys. So basing on this equation, what thermochemical equation can we write? Conversion factor rather. So something similar to what we've done earlier. Like this. So kindly please type your answer sa chat box for the conversion factors that we can use. So based on the thermochemical equation, kindly give me your conversion factor. Okay, so Jamir has his answer. Pwede mo nang tanggalin si 0.062. Conversion factor lang naman na ating gusto. So you can write one conversion factor is 25.7 kilojoule per mole, or 1 mole rather. 1 mole, to be specific, 1 mole of NH4NO3. Nisha also has a similar na answer, but this time, reciprocal na. So you have 1 mole NH4NO3 over 25.7 kilojoule. So copy natin ha sa PowerPoint. So in here, the conversion factors, let me abbreviate it as CF for our reference, as given by our classmates, are the following. You have this one. Or also, we can have the opposite one. So from Yisha, we also have 1 mole of NH4NO3 divided by the (25.7 kilojoule). So which one do we choose ngayon? Again, the idea here for us to be able to get the correct answer is that dapat whatever conversion factor we choose, it has to be written such that ika-cancel out niya ang unwanted na unit. The unwanted unit here is the mole, since ang ating hanap is the heat. And alam naman natin na ang heat, ang unit niya is either joule or kilojoule.
Sir,
Yes, please.
i-times yung 0.062 sa 25.7 kilojoule.
Yes, that's the idea actually.
Since
So, pwede
ang
naman
1
itong
mole
ginawa
ilagay
ni
sa...
Jamir. Sorry, Paul.
Wala sir. Okay na.
Okay. Actually, tama naman itong ginawa ni Jamir dito. But actually, what you can do, pwede na lang isahan ang pag-solve. So you might skip na lang the actual solving ng moles and dire-diretso ka na lang ng sulat. So that instead of solving 0.062 moles, we can then write the following. So sorry for cutting you off. So we have the following. Based on the conversion factors our classmate has given us, ang pipiliin natin ngayon is, on the numerator, we write 25.7 kilojoule. And that is now divided by the 1 mole of NH4 and O3. So again, if you notice carefully, the way that we wrote this, ang moles natin na unit, they will all cancel out. And ang matitira na lamang is the 25.7 kilojoule. So sige nga, can you please compute for me, how much will this one be equal to? So using your calculators, how much will now the heat be equal to? So we have the answers coming in. We have Yisha, Clarice, Ivan, Chelsea, Max, Bea, John also. So they all seem to agree. They have very similar answers here. Si John na sobraan lang ng slash. Kaori as well has her answer. Same with Kyla. Okay, so let's check. The correct answer here should be the Q is now equal to 1.60 kilojoule. So that is now our answer for this particular problem. Okay, so I hope this one was understood. So na-follow lang ba guys our problem number 1? So Kent also and Jamir have the correct answers as well. Any questions so far on problem number 1? Questions, clarifications, violent reactions?
Ito
think wala na, sir.
Okay, thank you, Ken. So now let's try to proceed to the next one. So for this one, you have problem number 2. So this time you have the grams of methane gas that you need to burn so that you should be able to get 500 kilojoules of heat. Again, same pa rin ang procedure natin, guys. First, we try to summarize first all the given information that we have, that we can use. And also, from the problem, it's stated here na we aim to get 500 kilojoules of heat. Now, what we're looking for in here is we're supposed to find the grams of the CH4. Again, to this one, we just start off with the given value that we have. So we were given 500 kilojoules. So we start with that one. So we have 500 kilojoules as our given information that we start off with. And then what we want to do is we want to find a way na mawala si kilojoule. So for the kilojoule to cancel off, we need to multiply it by the conversion factor. So on the chat box, can you state for me, ano bang tamang itsura ni conversion factor para mag-cancel out si kilojoule base sa ating thermochemical equation? So again, you can type or you can just unmute yourself. So what should the conversion factor be for this one? Okay, so Jamir has already typed the complete one. So that one is correct naman ano. If we type that one in, we will now see na by typing 1 mole of CH4 as Jamir has written down and divide it by the 890 kilojoule. Notice here, guys, we don't write the sign na negative or positive. We just have to write lamang the value. So mapa-positive man iyan, mapa-negative man iyan, we're only interested in the value of this. So writing it in this way, what you observe is that ang kilojoule na nasa numerator in the 500 kilojoule, it cancels out the kilojoule in the denominator ng conversion factor. So that doing so, we now get our moles na lamang na natira. And once again, so since that is not yet what we're looking for, so we need to further multiply it by something. This time, we need to have the molar mass of our CH4. For the CH4, para mabilis na lamang, molar mass of this one is equal to 16.043 grams per mole. This time, can you please dictate to me? So how should I write the conversion factor in here? Okay, so Vea already has her answer. So that one is correct naman, Vea, ano? So we put the grams on the numerator, ang mole nasa denominator, so that by doing so, 16.043 grams divided by the 1 mole. What we observe is that the units cancel out. And ang natira na lamang is ang grams ni CH4. Now, can you please compute for me how much will this one be equal to? So Vea has her answer. Can we hear from the others? So what should be the correct answer for this one? We have Chelsea with her answer. Other answers? Vince, also with his answer. Isha, Sandra, Jamir, Ivan, Clarice. So we all seem to agree that the correct answer here should be 9.013. Again, please express your final answer to the correct number of significant figures. So our final answer dapat, meron lamang siyang 3. Bakit 3? It's because this one, 500 kilojoules, only has 3 significant figures. And siya may pinaka-least number of significant figures in there. So typing that up, we now have our answer, which is now equal to 9.01 grams of the CH4. Okay. So I hope na follow lang si sample problem number 2.
Sir,
Yes?
Pwede balik lang sa sample problem 1 para mapicturean.
Okay. But actually,
Okay.
I'm gonna send you a copy naman of this particular na of our recording so that you can have something to look back to. Pero sige, kindly please take a picture now of this one for your reference. So, okay na ba, Paul?
Opo, sir. Done.
Okay. Problem number 2. So maybe somebody wants to take a picture. Shamir, please go ahead for your question. So bakit nga ulit po 3 significant figures? So again, if you recall from our IS na lessons, so what we have here is that pag multiplication or division, ang ating fina-follow is final answer should have the least number of significant figures. Bibilangin mo si 500 kilojoules, meron siyang tatlo. The 5 is significant, and itong dalawang zeros are also significant since after the zeros, meron kang decimal place. So 3 significant figures ito. 890 kilojoules. So this one is a little bit ambiguous. So it possibly has 2 or 3 significant figures. Let's say, for the sake of argument na lang, that there are 3 significant figures. And 16.043. So can you please tell me how many significant figures there are for this one? Okay, so Sandra got that one correct. There are 5 significant figures. 3 significant para sa 500 kilojoule, 3 significant pa rin para kay 890 kilojoule, and 5 significant figures for 16.043 grams. Kaya, ang masusunod in our final answer is, dapat mayroong 3 significant figures. So that's the reason why. So nalinawan ba tayo, Shamir, for that one?
Ay, sir. Nakoy question, sir.
Yes, please.
Dragod sa negative 890 kilojoules per mole. Wala na pulos ang yung negative, sir.
Okay. Again, we don't consider the negative sign when we're doing the stoichiometric calculation. A negative sign, it only tells us if it is absorbing or releasing the heat. But in the computation na mismo, only the value is important.
Sige, sir. Thank you.
Okay, thank you. Thank you rin, Shamir, for your question as well. Other questions before we proceed?
None na po, sir.
Okay, thank you so much. Sige, so that is how we can use the thermochemical equation to make stoichiometric computations. So if ever you'll be called upon to make similar computations in your jobs in the future, so how much mass of a fuel do you need to be able to obtain this much amount of heat, then you already know. Ano ba ang way to compute this one? Now we also have this one. So this one wasn't tackled in the video that we have sa ating introduction for this topic. So we have our energy diagram. So in the energy diagram, it allows us to represent in pictures the process that is going on. Like in the case of this one, meron kang exothermic process. Again, exothermic siya because negative ang sign. So what's happening in here is that we have the following parts. Meron kang upper na layer and a lower layer. On the upper layer, we then write the reactants natin, which is the carbon and the oxygen. On the lower layer, here is where we write the product na carbon dioxide. And to complete our diagram, we then draw an arrow pointing down, and beside the arrow, we write the value ng delta H, which is negative 393.5 kilojoule. So that completes our energy diagram. So you might be wondering, guys, how do we know? Do I write the reactant sa taas or sa baba na layer? So in here, since delta H is negative, what it means to say to us is that ang enthalpy ng products is gonna be lesser than the enthalpy ng reactants. Since ang products lesser than ang enthalpy niya, siya ang nasa baba. At yung mas mataas, ang enthalpy, yun ang ilalagay natin sa taas. And as for the arrow, kung saan ba siya pointed, we always draw the arrow from the reactants, itong ating carbon and oxygen, and we draw it pointing toward the product. So that's how we draw this energy diagram over here. Now this time, let's have another na naman na example. In this case, meron tayong endothermic na process. So in this case, what we have is the following. This time, you might notice ang reactant nasa babang layer. And the products, we write it on the upper layer. With the arrow pointing from the reactant to the product, always. So again, you might ask, Sir, why is the reactant nasa baba and the products is at the top layer? Again, we have to look at the value ng delta H. Since delta H is positive, what it tells us is that the enthalpy ng products is actually greater than the reactants. So kung sino man ang greater sa kanila, that's the one that we write on the upper layer. And whichever one is lower in enthalpy, that's the one that we write sa baba. And again, the arrow is written from the reactant pointing towards the product always. And to complete this one, we have our value ng delta H, which is positive 15.4 kilojoule. Okay, so let's try this sample problem number 3 so that at least mas maklaro sa atin how to draw an energy diagram. So in the energy diagram, we have the following parts. Now we're being asked to draw for this particular na reaction, the combustion of methane. So kindly please tell me on the chat box, or pwede rin na you can just turn on your mics, ano bang isusulat ko sa taas? Is it the products? Ito sila? Or do I write the reactants? These two. So what should I write sa taas? So the answers are coming in from Kent, from Sandra, from Kyla, Isha as well. So they all seem to agree na ang sa taas, we write the reactants. So that one is correct naman, ano? What we do is we write the reactants at the upper layer. And then, of course, itong products na ngayon will now go into the lower layer. Now, as for the arrow, that's the next one that we'll now try to draw. Kindly tell me, is the arrow supposed to point upward or pointing downward? So Kauri also got the correct answer earlier. So this time, please tell me, should the arrow point down or up? Okay, so Kyla, Kent, Ivan, Kauri, Chelsea, and also Sandra all say na it should be pointing downward. So that's correct. The arrow should always point galing sa reactants papunta ng ating products. So copy ko lang ito para hindi na mahirap na i-draw. So reactant, reactants pointing down to the products. And finally, to complete this, we just write the value of the delta H for the reaction, which is equal to negative 890 kilojoule per mole. So that's how we draw the energy diagram. So basically, it just gives us a visual representation of what's happening with regard to the enthalpy ng ating reactants and products. Okay? So let me turn it over to you guys. Any questions ba regarding the problem number 3?
None, sir.
Okay, thank you so much. So parang wala naman ano. Sige, so in summary, so what we've discussed is the following. So we've introduced in today's lesson the concept of enthalpy. Enthalpy is related to the internal energy. Enthalpy is just the internal energy plus the PV work. So enthalpy is defined by equation 6. And the change in enthalpy is defined by equation number 7. Now, the enthalpy is really important because for constant pressure processes, the ones that we encounter in our day-to-day lives, the delta H is actually equal to the Q. And also we learned that we have an exothermic process wherein delta H is negative. Pag exothermic, it simply means to say that energy is released to the surroundings. Now, when you have an endothermic reaction, the heat is now being absorbed from the surroundings. And in this case, for an endothermic reaction, delta H has a positive value. So that is our lesson for today. So that's the lesson proper. So finally, let's go to other reminders and other na announcements. So let me share muna the K-Hub. So let me share the K-Hub to you now. Ayan. So on K-Hub, if you try to check this one, you might have seen under sa week 1, so I've already added the recording of the synchronous session in here. So you can just rewatch the video and then skip around to the parts that you might have a little bit of difficulty understanding. And as well, aside from this one, aside from the recording, also available na rin ang PowerPoint ng ating synchronous session in here. So you can just download this one for you to be able to have something to study. Okay? So on your own time, please try to answer our formative assessment. So formative assessment, so please just answer numbers 1 and 2. Again, sa formative assessment, numbers 1 and 2 only. Okay? Never mind the numbers 3 and 4 muna. Answer numbers 1 and 2. The numbers 3 and 4, we'll just have to discuss that one on the next meeting. So before we wrap up this session, so once again, for the last time, let me ask you guys if we have any questions ba or concerns that we'd like to raise. Questions, concerns, violent reactions. Sandra asked, kailan ang deadline? Same pa rin. For all our formative assessments, ang deadline is 1 week after. Monday next week. Okay? Hope na answer, Sandra, ang question. Other questions?
Sir,
Yes, Ken?
sa ano po, Hess law, yung ano po dito, may navigate po dito. Saan pa ba to?
Okay. Again, yung Hess's law, wag muna. Since we no longer have time to discuss that one, we'll just leave that one for next week na lamang.
Okay po. So sa enthalpy, sir, ito po, answeran po to.
Yes. The only things you'll answer sa formative assessment, yung numbers 1 and 2.
Okay po. Thank you.
Okay, thank you, Ken. Other questions before we go? So by the way, thank you, Sandra, for the question. Sige, so at this point, so if there are no more questions, let me stop the recording. So once again, thank you so much for attending today's session.